So that's what I'm saying. Even it should
Hopefully,
not
we'll
be,
submit by Monday, sir. So,
no issue, no issue. Monday you can submit,
okay,
Monday, Tuesday, no
okay, sir. Thank you.
issue regarding that. But make sure that you're being on the same track with the task what I'm assigning. You should not be lagging, and at the end of the day, you should not struggle. Oh, so said and we forgot that, because only practice gives you the correct proper explanation of anything. Okay, so that is what I'm keen of, and hope everyone can see my screen. Sorry for the delay
Yes,
today.
sir.
I had some issue regarding power cut in our area, so it's been late. Okay, so down the line we'll check. There should not be, there should be any problem regarding this. Okay, so I'll make sure that there should not be any problem for power down or internet issue or anything. Okay, so yesterday we were discussing about few of a problem, like we have checked for linear analysis, modal analysis of various, sorry, of a cantilever beam. Now moving further, anyone have a doubt in that, like in a cantilever beam you are doing a calculation, hand calculation? Moving further, I'll just show a worksheet so that you can be familiar with that worksheet. Okay, let's see here. So how do we do a hand calculation if there is no, it is not there, fine, no issue. Okay, so I'll go back to the calculations of how do we do a calculation, and then into the classical approach of Excel. I'm talking about the calculations to be done with the Excel one. Okay, I'll just save somewhere. I'm not remembering the, okay, the calculations. So how we do exactly the calculation? Okay, to be frank, whatever your analytical or a classical approach. Okay, so see, considering one example of your first example, that is removing only the values of your structure, that is 4 by 10, I've changed to 40 by 100. Okay, so your load is 10,000, that is 100 kg, length is 1000 meter, width is 100, and thickness is 40. Yes, and your Young's modulus, if you are considering steel, structure steel, that is 2 e raised to 5, and Poisson's ratio, if you're considering, it will be 0.3. Okay, new value. Okay, so this way we just, what we do is we note down the input values. Okay, in the sense I'll put all these in a yellow color. That means we need to input the values of these. Okay, so then how do you calculate your shear? So shear is calculated with the equation of 3p by 2bt, that is b breadth and thickness, p will be the load. Okay, 3 by 2 or p by 2 by 3 bt, your equation of for a cantilever beam to calculate a shear stress. Okay, so when we do calculation, how do we do? So I'll just show you. Put an equation, equal sign, put a bracket, 3 into p will be, I'll click on to this and I'll close a bracket. So I'll take two brackets here. So it will be easy for me to make a division of this. Again, so second bracket is open, divided by second bracket is open, 2 into your B. B is nothing but 100 into T. And I'm taking the equation values here in your bracket. Okay. So that means when you click directly, your values will, your calculation value is updated. Understood everyone? How do we do it? Just multiply the terms what is present in the equation. Okay, then bending stress equation, that is my by I. So I've calculated m will be load by distance, that is, I'll show you, equal to your I and 10, that means I row and 10 column. So I'll select that into your length, that is I by 11th column. So I'll just enter it, you'll get the value. Okay. Similarly, just hold on a second. Manju. Here Manju. Class okay. So I'm showing that you can calculate, you are calculating your movement. Similarly, y will be I by 2, that is thickness by 2, the breadth by 2, t by 2. Okay, and sorry, y, I'm talking about I again, inertia. Centroidal axis is y, and inertia, it is calculated by b into t, that is L into h cube by 12 for your rectangular cross section for calculating your I value. Okay, then if you calculate by the same equation, that is m into y divided by I, your bending stress is calculated. Similarly, your von Mises stress or your principal stress is calculated as sigma x plus sigma y plus or minus sigma x minus sigma y by 2 plus, so 2 whole square plus tau xy, that is shear stress square. Here plus or minus by 2, your y, that is sigma y is the value or bending stress, whereas sigma x is 0 because that is 1D element or 1D beam. Okay, the other stress is 0. Sigma 1 will be 375, as same as you are calculating by the equation. So somewhere, one second, hold on a second, one equation was missing. Okay, you can see your principal stress is changing. Similarly, your thing is von Mises stress is changed because of the value used with tau xy, because one of an equation, sorry, one of a bracket was not closed correctly. So okay, so then you change, you'll get a principal stress. And deflection has an equation of minus fx plus 6 by 3l by 2. That is, if x is equal to l, then you can calculate directly. That is, f is nothing but your force. Force is selected here, and I value, L value is your length, 1000, again it is taken there. Yes, and then divided by EI is taken, calculated, and you're directly. Now I'm saying, why I'm saying this calculations we are doing with Excel. What is the use of doing Excel when we can do with a normal sheet or a calculation paper or in a WordPad or in a presentation anywhere directly? Why we are going to this calculation sheet? Because whenever I'm linking all the equations with the value required here in the inputs. Now for the next problem, similar cantilever problem, if I has 100 into 100 width. So I can get directly my values. What is a displacement? What is a principal stress? One is stress. What is a bending stress directly without any change. Only I've changed my input values. So this is the advantage of doing an Excel calculation. And there are many other shortcuts of using an Excel value. Okay, I'll share this. You need to look and practice to use Excel sheet for your calculations. It will be very easy by taking this, do a white background for this, and then directly you can paste this into your reports. So considering this, okay, you can directly paste your reports or taking a snapshot. You can directly place your calculations into any word or any presentation or report. You can directly place as an image. It will look as clarity of the calculations. Or you can directly from the Excel, you can directly take, copy, and just paste into your presentation. It gives you a proper picture apart from the equations. Okay, and if any changes is required, you can directly jump into there, and you can also do a calculation, a change in your report, or else image is also a fine thing. Okay, so that is what the advantage of using an Excel. You can change anytime. Your load is changing. Sometimes your load is changing, you can use it. Got it? So this is what the advantage of Excel. So please try to use your Excel itself for the calculations. Just delete this, and the other deletion, these are the, make it as green. You'll be understanding these are the results what you require. Bending moment, principal stress, one stress, as well as your displacement. Okay, so I'll share this Excel sheet for you people so that you can practice the calculations. Okay, any doubt here? Yes guys, any doubt? Why do you prefer an Excel for any calculations? So any doubt guys?
No, sir. Continue, sir.
Okay, fine. So I've shared you people the Excel sheet so that you can do the work, do the presentation, and try to use and calculation. And moving further, sorry, I'll take model itself. Moving further, we have a one more, as you have completed now, a model analysis of a cantilever beam, and also the other is the model analysis, sorry, free check and static check for, or strength analysis of a cantilever beam. Now for a cantilever, that is in simple geometry, which is very easy, you have done with one shot. Now what if your geometries are too complex? How do you work on that? For example, one of a project which was given from GE, in the sense General Electricals, as an open challenge to all the as an open challenge to all the conceptual designers to design an optimized bracket. Okay, you can see that a GE, General Electrical Engine, they are the engine developer, aero engine developers. Okay, once it happened that there was a failure in an aeroplane for an engine bracket. That means you can see here there will be one bracket which will be holding your engine. So there will be one bracket, your entire engine will be holded on the bracket. That is from outer case, your nacelle, and the engine core will be set out with the brackets, number of brackets, series of number of brackets will be there. That due to that failure, the whole engine was grounded down. You can see this. There is a bracket which will be holding your entire engine. Okay, so that they have given an open challenge to design an optimized CAD model. Okay, to design an optimized CAD model with minimum weight, and it should withstand the entire load. Okay, so in withstand the entire load. So the requirement was to submit a optimized design of a CAD model, that is a bracket model. Okay, and then use a material as titanium, aluminum, vanadium, that is Ti6Al4 vanadium. Okay, and minimum material feature defeaturing size was like thickness should be minimum should be 0.05 inch. Okay, that those all are covered in your for maximum diameter of a bolt holes they have given. Okay, on that basis we need to build a CAD model, and we should say that this model will be used as an optimized one. So one of our previous organization where I was working, so we took up a challenge for these conditions. We have designed and gave a optimized solution for them. Okay, but there was a number, we don't know what happens. We submitted to our managers, they have given their own presentation what had happened, we didn't took into the other scenario. Okay, so this is what we built and we solved. So now I'm saying that we'll use the same conditions and material also with the bolt hole, the CAD model what will be used. Okay, so you can ask, sir, how do we get this load conditions? What are these loads? From where we do get these loading values? These loads values will be calculated, that is by the supplier or main as a customer, what we call, they will be calculating or deciding by a various number of test, field test, or sometimes by the previous experience. They will be having a huge data with them, and they will be converting those data, that is a dynamic data, into as a static load values, as a critical load values. That means the critical in the sense, if these loads are passed, then we can say your model will withstand for any other loads experienced by that plane. Okay, so any other loads experiencing by that plane. So the loads will be initially tested and they will be provided as an input. Okay, now so there was a challenge and everything. This was the conditions, that is one is vertical, other is horizontal, the third is inclined, and the fourth was there we didn't made it with the clevis, that is at the shaft at the interface. Okay, understood? So we'll go further. I'll show you the CAD model. They can see how your presentation should be. I've already shown that. Okay, so I've already shown you how your presentation should be. So I'll just briefing you the requirement. The material properties are this. I'll share that presentation also to you people, not the original one, the yesterday which I have shown you guys. Okay, so I'll be sharing the CAD model as well as the material or the presentation which I have shared you yesterday, so that you can easily work on it. Okay, next. So how do we do that? I'll just first I am taking that as model analysis. I'm preparing, as you should be having a habit of doing a model analysis initially after building up all the setups, and then moving further to your static analysis. Okay, so I'll just drag and place over the model. The static also will be imported. So what I'll do, I'll just import the CAD model, right click, import CAD model, and you can see the CAD geometry is updated. Next, click on to model, edit, that is your mechanical modeler will open up. So you can see that your CAD geometry is being updating. Yes, okay, so not, this is not the one. Right click, import, browse. Okay, models. Sorry guys, again the same one previously, which is not correct one. Okay, now the geometry has been updated. Sorry, it has not been updated. Okay, now your geometry has been updated, and you can see you will be having modal as well as static both. Okay, so for this I'll just save the file, and then you can go back to geometry, look at the geometry. So what material your geometry is? It is default as in structure steel, but we are using which material? We are using, for that I need to refresh your, go back. Okay, so before that I'll just update the material data. So in engineering data, I'll edit here, click on right click, edit. It will go to your filter engineering data. I'll click on to engineering data source, and you'll get general materials. You can get the list. If you find an aluminium, here is fine, otherwise you need to add up. So I'll just consider with the other. I check whether it is available, the ready available. It is titanium, explicit materials, just hold on.
Sir, in the material description, sir.
Yeah, in material description.
Hello, sir.
Yeah. Tell me.
They mentioned a few numbers next to the material's name, no, so like AL6, something like that.
Yeah,
What
that is.
yes.
It is The aluminium, that is tungsten 6Al, in the sense tungsten 6% of aluminium and 4% of vanadium. It is a mixture of alloy of tungsten, aluminium and vanadium. Okay, if you would have studied in your metallurgical subject that the mixture alloys are made for various properties, is getting a combination of various properties. Okay, so that's the combination they have used for tungsten, that is titanium, aluminium and vanadium. For all the three combination they have used that material. As you can see in the screen, that aluminium 6061T6, in the sense aluminium has various composition, that is having a alloy number as 6061T6 7037, that is the combination built of materials. Okay, so that is what they have given the naming, or shortcuts generated by for the particular material. Yes, got it.
Yes, sir.
Okay, so aluminum, I saw somewhere titanium is there for this. We'll check. Tan 10% titanium, titanium 2, Teflon. Yes, you can see this. Titanium 6%, aluminum 4%, vanadium. I'll just click onto the plus button. So now I'll off this. I'll off this. Sorry. Here a titanium aluminum is there. You have the density of that material and material variables. All the material variables are available on this. Okay, on this material. So what I'll do, I'll just off this, go back to the project folder and refresh the project folder. Okay, and then I'll go for to the geometry in the mechanical editor, and I'll click on to tungsten 6%, aluminum 4% vanadium. So your material has been updated. You need to cross check every time which material your solver is been using. That is very important and it is required too. Okay, and then select here on the meshing. If you want to build a coordinate system, I'll just create one coordinate system. I'll explain why I have created this later. I'll just keep it as it is. Okay. Now the meshing size at its course, what I'll do, I'll just take as medium and span of angular as a medium. Then I'll just generate a mesh. Okay. Now your geometry is being meshing. You can see your geometry has meshed with TET 10 elements, sorry, TET 4 elements. Okay, tetrahedral element. Okay, now if you don't take any boundary condition, then this becomes free model analysis. If you are taking a load or a boundary condition, then it becomes fixed modal analysis. So I'll insert a fixed support because that is only one geometry. I'm not considering any free check because I'm sure that I'll be getting 6 rigid modes. Okay, and then the boundary condition is applied and I require going to analysis setting. How many modes are there? I'll just increase to 10 and I'll insert deformation and give a solve. So your model valid data these form elastic is required. Okay, going back to your engineering data, it is saying that your tungsten aluminum material requires few more, that is it has given with only few data with the temperature, your density is updated, there is no e value. Okay, it is with an explicit value the material property. Or else what I'll do, I'll go to engineering. If not, you can just add here a new material with tungsten, aluminum 6 aluminum 4 vanadium. Okay, so that your properties will be added directly to your, that is, sorry, okay. So isotropic properties are required. Will add for your tungsten aluminum material. Okay, what all required? The Young's modulus and Poisson's ratio. So what is an Young's modulus? I'll enter for your Young's modulus. So go back to the presentation. What is your Young's modulus? That is
So like
130.
all these details will be provided to us, no sir?
For few materials, it will be provided. For the general materials, like for example, if you are considering a general material in engineering data, for general material, any cast iron, magnesium, all the data are available standardly into your structure. For example, titanium, aluminum itself. The data is
No,
already
no sir.
there.
Like I'm not talking about the software, sir. Like they're given you that project, no sir, from
Okay. Yeah, the
General
material
Electrics.
data will be, yeah, the material data will be provided. Otherwise, see, they have mentioned the material which should be used. Otherwise, if they have mentioned only the name of a standard material what is used, you need to take, as we have considered, the material property source as a web mat. There is a website in a, you Google, you can search as a web. These web mat in the sense, these are the standard material input data from the source. Okay, that is web mat.
Sir,
Or
can't we do that combination inside Ansys itself, sir? Like
sometimes what up, yeah, tell me what exactly combination in the sense, you
can we
can't do
take
that.
like we have the properties of titanium, aluminum, and vanadium separately, no sir?
Yeah,
We can take titanium and add 6% of aluminum, and then
no,
other
you can't
percentage of
do
vanadium.
this answers. No, you can't do, yeah, that values would not be a correct thing. Okay, but you can't do that in answers. Okay, you can add a material to your engineering data. It is not to get a new material out of the present data. Okay, so
Okay, sir.
these are the tested data what I'm talking about. If the customer has provided you, that is fine. If he has not provided, you can go to webmat and get that. Or there is a particular, if this bracket is built by some particular standard manufacturers, they will be having their own catalog, material catalog. Okay, they will provide that. Or if in aerospace, we directly refer to one of a like a data book for the material, that is MMPDS, material management data, what we call as data source. Okay, that is MMPDS. So that are the standard ones, they are being considering from so many years, because they are being tested and written in a table form, or what we call as an from the trusted source. For example, G as well as Rolls-Royce or Airbus or Boeing in aerospace, they follow their own catalogs. They don't trust on any of other material built or tested data. They have their own testing labs. They will be investing huge amount of their resource as well as money to get the material of the data. Okay, so they have their own setup and they will be having their own labs to test these data. Okay, or else
Okay.
there are general material sources, that is WebMat, or you can also go with MMPDS. Okay.
Okay, sir.
Okay, and going back to here, I'll be adding here. We know that what is our, sorry, that is 1.13 to 113.832 GPA. I'll just add in terms of GPA and then convert it to, sorry, to this isometric Young's modulus here. Sorry, just delete this, change to the unit to, okay, Pascal PSI. GPA is not there. It's fine. We'll add
You
it.
write in terms of E, sir.
Okay. So your MPA becomes the value of Young's modulus, and the Poisson's ratio. Poisson's ratio will be 0.342. So your bulk modulus and shear modulus will be updated, and you can also add your density. I'll click here, density as well as every other material details you can add up. Just drag to that and you can add the tensile strength, tensile ultimate, yield ultimate. Okay, so that can be added up directly. What is an yield here? Already it has been given. The yield strength is 903.2 MPa. Okay, and for the ultimate we don't know the value. I'll just add it as more as 1200. Okay, yes, you can take these all as an input and update to your material. Okay,
Sir, is a tensile ultimate strength compulsory, sir?
tensile, no, it is not compulsory. It, only 2 is sufficient, and when you are going for acceleration your density is also required. Otherwise that is not required at all. The other things are not
Okay,
required
sir.
at all.
Okay, okay,
Okay.
sir.
So the density value, I'll just add that also, so that, okay, here density value is not added, but you should add it. It is not
Sir, it was
required here because
it was in the
previous
inbuilt thing, sir.
presentation.
Here, sir. The fourth
You can
material.
see 4419. You can just update that, okay? And once that, you go back, you refresh the project, refresh project, and then go to your geometry and change that to the new material. So now your new material is updated. You can just solve the required problem. Yes, your deformation, that is your modes are being generated. I'll just evaluate those. You can see your number of frequencies. Okay, once this is done, okay, once your geometry and frequency material has been updated, and then you can go fix the support for the static analysis, okay, and apply the, sorry, forces are not applied because it is bearing loads are being added, okay. Bearing loads are added vertically, horizontally, and at 45 degree. You understand what bearing loads we are talking about? As this is a bracket, you can see in the figure as they have shown, this will be having one interfacing or what we call as a shaft kind of thing, which will be locked up, and there will be one more bracket attaching at the center. So that load will be having in 3 different directions, okay. With that, one more load will be like torsion. Torsion we are not considering because it will be a huge again for you. Now you consider all the 3, that vertical, horizontal, and inclined. So this sleeve, or what we call as an shaft, which is introduced between the bracket, will also having a fitting with the bearings, okay. So for example, what kind of typically you can imagine is like your car back door, you lift your what we call hood, we generally call it as hood, what we call you call as a dicky, okay. When you pull that, you'll be see that there is one bracket your car dicky is attached with. Yes, yes or no?
Yes, sir.
So similar kind of a bracket will be used to also hold the your whole entire engine, okay. Whole entire engine will be held by your air wings, okay. So that, for that the bearing load will be considered for this. So where it is attached, so the bearing load we are selecting on the surfaces of each. Now the direction again, in which direction your bearing loads are. So I'll consider this as a component in the sense your coordinate system. Whether your coordinate system is similar to your bracket or loading conditions, no, because it has been built in other coordinate system as required for your aero engine, okay. So for that, what we'll do, we will create our own coordinate system, okay. Where do we create? Here on the center of this both the lug, I'll create my coordinate system at the center of the lug. Okay, so now you can see the same as your global coordinate, your bracket has been generated, or sorry, your coordinate system has been generated, but I require this coordinate system to be horizontal and vertical with respect to my geometry. So for that, what I'll do, I'll go back, I'll take this default geometry selection, I'll select the base and click on it. So now you can see your base is inclined as same as that of your coordinate system. So now you can say that your loading or your bracket coordinate system is similar to your loading condition, or the local coordinate system is similar to your loading conditions. Okay, yes, hold on a few seconds, guys.
Can you repeat this, sir?
Yeah, sure, 2 minutes. You can see that yeah, I'll just delete this coordinate system. Okay, now you can see that your coordinate systems are not with respect to your model required coordinate system or the loading conditions what we are showing here in the given bracket or the loading condition. You can see this, the bolts are attached to the base and your load is upward, horizontal, and with an incline of 42 degree to vertical. Okay, now the question is whether your bracket, when you are applying a bearing load, you have selected both the surfaces. Okay, now if you select your coordinate system, whether in which direction for vertical I need to apply. If I consider this way or the other way, in which direction your coordinate system will be applied. Yeah, it will be not there. So what I'll do, we will create a coordinate system. I'll take as CS1. Okay, to make this, I want to make sure that it should follow or look in between these two lugs, so that it will be more clarity for me to select the directions or my loading conditions. Okay, now you can see it is at the center, but the coordinates are similar to your global, your z, y, x, because it is being taken as a default values. Now I want to change this to a geometry to my requirement. What I'll do, I'll just select the geometry, because here we have an option, fixed vector or hit a point, normal, or geometry selection. I know that this base is perfectly flat, which will follow my requirement. So what I'll do, I'll select that and click on that. You can see your coordinate system has been changed respectively. Yes, now you can see your global x and y are different from each other. Your z axis is x now. You can see the directions values are changed from global coordinate to local coordinate system. Yes, now what I'll do, my bearing loads, what I'm applying. So if I consider the component, okay, I'll not consider the global coordinate system, I'll consider CS1, which I have generated locally.
Sir, while applying bearing load, sir, like, can we select both the bearings and put one load now, sir? Like, for bearing load itself,
no, you can select and apply. There is no issue. It will be at the center. But when you apply the load, is the load will be acting. You are taking the loads as you are considering 8 lbf, they are for both the bracket. In the sense, you need to divide this into 2 and apply. I'll show that also. As you said that your faces, as you selected, as we have selected each individual bearing loads. Okay, now we have applied. Now I have considered the coordinate system, and in which direction we are considering as vertical, that is our negative x. So that we have converted the value into Newton as this. Okay, what I'll do, I'll just go put negative value and paste it. So you can see this, your loads are acting on both, but in general showing it will be like your one. When you go and present this way, people might get confused. For that I'm taking as each individual bearing loads. Okay, when you say that, sir, both are selected but the arrow mark is one in one, but it will be considering both the surface.
Okay, sir.
Okay,
So even if it
Okay.
shows arrow mark for one bearing, it will be applied wherever the red face is
for
visible.
yes, your selection of the faces. Okay, but for clarity I'm taking only one, so I'll ignore the other one. Okay, so it will be where more clarity for you to for the selection. So again, what I'll do, go to component, coordinate system, local coordinate system, your negative value, add it. So your both the loads are been, or bearing loads have been applied. Okay, yes, so your loads has been applied now. Now
Sir,
the
like
fixed
you were
support.
telling that you had to divide it by 2, no, sir?
Yeah, that is there. So the value will be divided into 2. I'll copy that and just update that one. Okay, so negative value. Okay, your values is updated, and now the fixed support, as your bolted holes are being fixed. Now you can see your static bearing loads are applied, as well as your bolt holes are being fixed now. So this is your setup required for static analysis. Then insert displacement, insert equivalent stress. So just give a solve. So this is one condition, that is you have applied for vertical. What for horizontal? What for inclined? And what will be for your required combined load cases? Okay, so you can see that all the 3 conditions are there. You need to update all the 3 conditions. Okay, so as of now we have done for vertical load case. I'll share this geometry. You can try for horizontal as well as a presentation. You can try for horizontal. If you're not getting it, we will do solve on Monday again for vertical, horizontal, inclined, as well as your combined load cases. Okay, so we'll stop up here today, because again the next batch will start and we will meet up on next Monday. Sorry for the delay, only today it has due because of the power shutdown at our area. Okay, make sure that by Monday your system has been updated with your software. If any issue you are falling, just let us know, me or Vijay, so that your issue has been solved. Yes, guys.
Okay.
Yes, sir.
Okay, fine.
Can
Any
you
doubt
share
here?
this geometry, sir?
Yeah, I'll share the geometry, as well as I'll be sharing here the presentation. One presentation which I have showed yesterday. Or the presentation I have already shared with you people, I hope.
Yes, sir. One PPT is shared already.
Okay.
Regarding this the geometry and the values, sir, properties.
No, the property is already
In order to
no, the property is already been what the presentation has been shared, right? The property values are there in the
Yeah.
that presentation.
Not this PPT, sir. He shared the other PPT yesterday.
One second, let me check.
You shared that some PPT of your students, like previous batch student.
Yeah, that previous batch student only you can use as a reference to that.
Sir, that you shared regarding the how to make a PPT.
Yeah, I do agree. I'll make you clarity.
Yeah.
Okay, he has used the material properties what I have explained in this presentation itself. The same material property he has used and updated in the presentation. Okay, which I have shared you. He has used a material where which material he has used. The slide number 6. You can go there and see the material being used there. Okay.
Okay,
All
sir.
the same data he has used.
Yes, sir. Yes, sir. That General Electric presentation, sir. The problem statement, that PPT can you share, sir?
That would be a trouble, but you don't require that as of that. You are talking about this. This cannot be shared. Okay. Try to
Loads value, sir. Is that included
it is
in
there
the?
in the yeah,
Okay,
it
sir.
is there in the presentation what
Okay, sir. Okay, sir.
I've shared yesterday. Okay. Don't worry about that. Your loads as well as the boundary condition, every other descriptions are there. Only I need to share the geometry so that you can try with other cases. However, I'll be explaining you on Monday the same all the three again. Okay. Yes, guys. Any doubt now?
No,
So where
sir.
is the inclined load, sir?
Sorry.
Where is the inclined load, sir?
This I hope they have not considered in this presentation. And the one which I have shared you, even in that also they have not considered. I'll be sharing that with you people on Monday. Okay. You just try with the horizontal and inclined both.
Okay,
Sorry,
sir.
horizontal and vertical both, so that you'll be okay with the software. Okay.
Okay, sir.
Thank you, sir.
Okay. Thank you, guys. We'll meet up on Monday again. Yes.
Yes, sir. Thank you, sir.